Dear learners, today I welcome you for exercise 1.2 of chapter 1, grade 9 mathematics. Today we are going to solve first three questions of this exercise 1.2. We will solve question 1, 2 and we will solve question 3 as well. In next lesson we are going to solve question 4, 5 and 6. So before solving question 1 and 2 and 3, we must know about the types of matrices. If you see here in question 1, we have to determine that either it is identify unit matrix, or you can say identity matrix, row matrix, column matrix, or null matrix. How you can determine that this is null matrix or square matrix or identity matrix or which type of matrix? So before identifying the type of matrix, you must know about the types of matrices. So first of all, we are going to discuss about identity or identify unit matrix, row matrix, column matrix and null matrix. In previous lesson, we have discussed about row matrix, rows, number of columns and column matrices. Again, we are going to discuss about this. So first of all, what is identity matrix, or in other words, you can say identity unit matrix. Identity unit matrix. A diagonal matrix is called identity matrix. When we say diagonal matrix, it means that in that matrix, all the diagonal entries, if you see this example, A matrix is given. This is diagonal. 1 1 1, these are in one sequence. This is non these are zeros which are in the upper triangular form, lower triangular. We will not count these. If all the diagonal entries are 1, it is written here, if all diagonal entries are 1, it is known as identity unit matrix, or you can say identity matrix. It can be 3 by 3, it can be 2 by 2, but remember that diagonal matrix will always be in a square matrix, will be having equal number of rows and columns. Next, which we are going to discuss is row matrix. Here the type row matrix is given. A row matrix is called a row matrix if it has only one row. For example, given example is given here that matrix M is equal to 2 minus 1 7. These are the real numbers given. So this matrix is indicating that this is row matrix. For example, if I do here, I take example of row matrix. Row matrix, for example, I say that A is equal to, I have a matrix A which is equal to 1 3 7. This will be known as row matrix because it is having only one row. And in previous lesson we have discussed that horizontal entries are known as rows. So if we have a matrix in this way, in which only the entries are in columns in a vertical way, that matrix will be known as column matrix. That matrix is known as column matrix. And if we have a matrix, for example, I name it as B 1 0 0 1, it will be known as identity or identify unit matrix, because we have discussed that if the entries, all the entries or all the numbers in the diagonal are 1, then it is known as identity matrix. So we have covered three types of matrix. One is row matrix, second is column matrix, and third is identity or identify unit matrix. In this question number 1, if you see, we have one more matrix type of matrix, that is null matrix. If you see, Null matrix is the matrix in which all the entries or in which all the numbers are zero. It is written here that a matrix is called null, or even we can say it as zero matrix if each of its entries is zero. For example, I say that I have one matrix A, and all the entries of this matrix, if it is 3 by 3, 3 columns, 3 rows, all the entries of this matrix are zero, or you can say all the numbers are zero. We call it null matrix, or even you can name it as zero matrix. So we have to apply these four types of matrices in the first question. So now we are going to solve question number 1 of exercise 1.2. So in question number 1, you have to uh, identify from the following matrices that which one is identify unit matrix, row matrices, column matrices, or null matrices. If you see this A1, I say that all the entries of this matrix is zero. So I solve it here. Question number 1, matrix A, all the entries are zero, so it is known as null matrix. As we have discussed the statement of null matrix, that if all the entries are zero, it is known as null matrix. Now we have another matrix, that is B. It has elements, or you can say real numbers, that are 2, 3 and 4, or you can say the entries are 2, 3 or 4. So B is equal to 2, 3 and 4. As you can see that in this all the entries are in horizontal way, or in the horizontal sequence. So it will be known as row matrix. Then we move towards next matrix. In this all the entries are in vertical form, so we will name it as column matrix. So C is equal to 4, 0, and there is one more element, that is 6. So my dear learners, it is your column matrix. All the concept which is based for this these questions is that you must know the types of matrices. You must learn all the statements of these types of matrices. So whenever you are going to solve such questions, you must know that either it is null matrix, row matrix, or column matrix. So we have done. Now I have one more. I am going to solve one more part, that is D matrix. In this elements are 1, 0, 0, 1. If you see all the diagonal elements are 1. So we will say that this is identity matrix, or you can say identify unit matrix. So D is equal to 1, 0, 0, 1. So all the diagonal entries, if you see here, are 1. So it is known as diagonal, sorry, identity matrix, or identify unit matrix. So in the same way, you have to solve E part, F part, and I am leaving it on you so that you can do practice of some unknown, unsolved questions. So now we are moving towards question number 2. In question number 2, again we have to identify that which type of matrices are given to you in this first part, second, third, fourth and fifth. And they are asking that we have to tell either it is square matrix, rectangular matrix, column, null, row, or identity matrix. And in previous question, we have covered about identity matrices, that all the diagonal entries should be 1. We have covered about the row matrices, we have covered column matrix also, null matrix also. But in this question, two more types we are going to discuss, that is square matrix and rectangular matrix. So with the help of one example, I am going to explain you about square matrix and rectangular matrix. So till here we have done question number 1. So if suppose I have one matrix A and all the entries are non-zero, or if any of the entry is 0, you can say, for example, I take 0, 3, -1, 2. So what is happened, that here we have two rows R1 and R2, and we have two columns. I name it as C1 and C2. So two rows and two columns are there. If we have number of rows equal to number of columns, remember this thing. If we have number of rows equal to number of columns, then it is known as square matrix. It is your square matrix. And you have seen that here we have two rows and two columns, which can be set at 2 by 2. So it will be your square matrix. Now let's see what book says about this property. Square matrix. It is written here, a matrix is called square matrix if its number of rows is equal to its number of columns, as I said in the example, that A is equal to 2 minus 1, 0, 3. Two rows are there, two columns are there, so it is 2 by 2 matrix. It is known as square matrix. One more example in which three rows are given and three columns are given. It is 3 by 3 the order of this matrix. It is also your square matrix. So now what is rectangular matrix? A matrix is called rectangular if the number of rows are not equal to number of columns. So here example is given. Let's go to the board and I give one more example there. We are talking about now rectangular matrix. A rectangular matrix is the one, for example, I say A is a matrix in which the entries are 2, 3, 7, 9, 1, 4. How many rows are there? Row 1, row 2, and row 3. And how many columns? Two columns are there, C1 and C2. So you can see the number of rows are not equal to number of rows are not equal to number of columns. So it will be known as your rectangular matrix. In other words, if you see, the matrix is having the shape like a rectangle. So in rectangle, what we have? We have two sides of equal length and other two sides of equal length. So if you have number of rows not equal to number of columns, you will be having this rectangular matrix. Now let's solve question number 2. So first part I am going to solve. First part is -8 to 7. These are the entries. -8 to 7. And then one more row is given, that is 12, 0, 4. The entries of next row are 12, 0, and 4. So how many rows are there? Two rows are there, R1 and R2. How many columns are there? C1, C2, column 3, that is C3. So number of rows are 2 and columns are 3. They are not equal to each other. So number of rows and number of columns are not equal to each other. It will be known as rectangular matrix. I hope so you are clear about this. Now I am going to solve one more part. This was the first part. I am going to solve question 2, second part. In second part, the entries are in vertical form 3, 0, 1. 3, 0 and 1. So how many only one column is there, so we name it as column matrix, because they are asking about that which type of matrix is this. So if you go in more detail, we have 3 rows here and 1 column. You can say that it is rectangular matrix also. But if you say that it is column matrix, which is the most suitable answer here. Now I am going to solve question number 2, part 3. The entries are 6, minus 4, 3, minus 2. Question 2, part number 3. Entries are minus 6, 4, 6, minus 4, 3, minus 2. 6, minus 4, 3, minus 2. So how many rows are there? 1 row and second. Row 1, row 2. How many columns are there? 2 columns, C1 and C2. So it is that number of rows is equal to number of column. So it is 2 equal to 2. So it will be known as square matrix. So I hope so you are clear that how we have to identify that either it is rectangular matrix, column matrix, row matrix, or scalar, or whatever the option are given. So fourth part is again the similar as we did in question 1, part number D, you can see here. Now fifth part is also I am leaving on you, but I tell you here that what is going on here, that here we have 3 rows and 2 columns, and number of rows and number of columns are not equal in this part. Question 2, fifth part I am talking. So it is your rectangular matrix. So again we have sixth part in which uh, horizontal entries are given. It is known as row matrix. This one will be, seventh part will be your column matrix. I am leaving these parts on you so that you can do practice of such questions, but I have explained it. And then eighth part is there, and you can see that the number of rows and number of columns are equal in this, 3 rows and 3 columns, so it will be your square matrix. Then we have ninth part, all the entries are 0, so it will be known as null matrix. This is the most suitable answer, but if you go in more detail, then you can say it that it is rectangular matrix as well. But the main answer for this is that it is null matrix. So we are done with 2 questions of exercise 1.2. Now we are moving towards question number 3. And in question number 3, you can see that we have some matrices, and in this we have to identify diagonal matrix, scalar matrix, and unit identity matrix, which is also known as identity matrix and identify unit matrix, which we have covered in question 1 and question 2 as well. So now we are going to discuss about 2 more new types of matrices. One is diagonal matrix and other one is scalar matrix. So if you see here, what is scalar matrix? A diagonal matrix is called scalar matrix if all the diagonal entries are same and non-zero. So example is given here that all the entries in the diagonal are same. In this matrix, in this example, all the entries are k, and but it should be non-zero entry. where k is a constant that is not equal to 0 or 1. If it is equal to 1, then we name it as identity matrix. So it should not be 0, not be 1, but any non-zero value it can be. Is 2, all the diagonal values are 2, so it will be known as scalar matrix. Here all the diagonal values are 3, it will be known as scalar matrix. So let's see one example which I solve here. We are talking about scalar matrix. Let's suppose we have a matrix C in which we have entries under root 3, 0, 0, square root 3, or you can say under root 3. So all the diagonal values are non-zero and not equal to 1. So it will be known as scalar matrix. So now I hope so that you are clear. Now let's move towards diagonal matrix. So first of all, see here the statement of diagonal matrix. A square matrix A is called diagonal matrix if at least any one of the entries of the diagonal is not zero. And suppose there are zero values, or the values are not same, would we name it as diagonal matrix. Or not zero and non-diagonal entries are zero. So in previous examples of identity and scalar, we said that in identity the diagonal values should be 1, and in scalar they must be same but non-zero and not equal to 1. But in diagonal we name that that in diagonal matrix the value should be non-zero, and if it is not same it will be known as diagonal matrix. For example, I have value 1 2 3 in diagonal, so it will be your diagonal matrix. If you see here in the example of diagonal matrix, they have taken this example 1 2 2. 1 is not same to the value of other two values which are in the diagonal, so it will be your diagonal matrix. This is your diagonal matrix 0 1 3 if the entries are, so it will be your diagonal matrix. Even if you have a matrix in this way, for example, I say I have a matrix E which is equal to 0 0 0 0 3 0 1 0 0. This is also known as diagonal matrix. Now let's move towards question number 3. I hope so the types are clear to you. So question number 3, I am going to solve first part, and first part is that A is equal to 4004. Very good question is given here, that A is equal to 4004. Now my dear learners, see the entries in the diagonal, this is your diagonal, are not equal to 1, are not 1, but they are same, but they are non-zero values and not equal to 1, and we have said that if we have such entries we name it as scalar matrix. You can see here we have taken the example. So now in this question we name this matrix as scalar matrix. Now next part of this question is B, which is 2 0 0 minus 1. This is also a good question, that B is equal to 2 0 0 minus 1. And if you see here, both the values in the diagonal are not same. They are non-zero but not equal to 1, and they are not same, and we name this as diagonal matrix. This is your diagonal matrix. As you can see here, we have discussed two examples in diagonal matrix as well. So I hope so you are clear till uh, this part of question number 3. Now I'm not going to solve the C matrix because 1 1 are in the diagonal. It is your identity matrix, or you can say identify unit matrix, and D is also your diagonal matrix. I am not going to solve this one. So let's solve E part. C and D are your practice questions. E is that 5 minus 3 0 1 plus 1 is equal to 5 minus 3 0 1 plus 1, and this is 0. Now we have to solve this. First of all, 5 minus 3 gives you 2, 0 0 1 plus 1 is 2. So if you see, all the diagonal values are same. And how many values? They are two values, 2, and this is also one value is this, one value is this. So it is again your scalar matrix. So I hope so you are clear about first three questions, and in this class, in this session, we have to discuss only about first three questions of exercise 1.2. So if you have any question related to question 1, 2 and 3 of exercise 1.2, you may ask me, and I hope so it is clear to you as well. So thank you so much, and do not forget to hit the like button and to subscribe my channel. Thank you.